Does anyone know? I'm trying to figure out how to put text on my Twitch page. Like, I literally can't figure out. I want to put a text explanation on the page below the video. On the page without it. The video. Now it's echoing. Okay. Add your bio and oh, I have to go to my actual. Oh, edit panels. Okay, they've changed it since last time. Okay. Add a text or image panel. What is... Okay, I got it. It's going. It's going. Description. Intense work focused on producing the I'm editing a little panel. Yeah, don't Google crank session. Maybe it's a bad name. Maybe we need a better name. You're working on the most. It's time. Until the timer finishes. But if okay. I just submitted a panel. I don't know how to move. Oh, there we go. Okay. So maybe that shows up. I don't know if that shows up dynamically for people or if they have to like, you know. Next is a $3 TTS. Oh, wait, what? Okay, what I haven't mastered is like the camera. And also not editing two texts. Wait, guys, in OBS, if you copy a text item rather than making a new one, it's like it changes both. I can't. Do you know what I think about that? I think this. All right, so I have to make a new one. That's so lame. Okay, I'm going to change this called "What is going on?" Question mark. And then I'm going to put this. We have to get the camera up. All right, we have a camera. That is great. Okay. Ugh. Dude, I can't. This interface is so bad. I don't want to snap. Okay. Okay. Can we call it a Benny session? No, because I don't want to go insane. The goal is to be productive, not to go insane. You need to right click with the mouse and use paste duplicate instead of reference. Well, I didn't say reference, I said Control C, Control V, which everywhere else in computers does not create a reference, it creates a copy. So like, again, don't be telling me I did it wrong. I'm not going to put up with that. I'm just not. Although I do appreciate the explanation. The not put up with that is to the dude who I timed out. It's like, look, at some point, I just can't deal with the computer gaslighting that happens all the time. All right. It probably would be more dramatic if I put a timer on the screen. But I kind of don't feel like researching what's a good timer plugin that will actually just work and not derail me for an hour. So I'm just going to use my iPhone. I also, though, I'm going to make a thermos full of warm tea that I can fall back on. Because, again, I'm not going to be getting up during the thing. So, timer. 3 hours, 0 minutes. Teetering crank is cheating? No, it's not. Because you may need caffeine. Will the chat be hidden? Yes. The entire monitor will be off. So again, if there's an F in the stream, I won't know. If the stream entirely goes down, I won't know. I will just keep going for 3 hours. And if I lose everybody, that's fine. I'll find out later. Snacks are on deck, though. I'm like staging all my snacks. Got catheter. I'm believing that I will be able to not have to go to the bathroom for 3 hours. We'll find out how much of an old man I am. All right, let me warm up some water. I also have this. So, tea. And then I'll be ready to go. I'm not even 20 years old yet. I am turning 20 in like a year. It's still going to be a few minutes before I start because, like, you know, normally while I'm programming, I'll get up and I'll make several rounds of tea. But I want to, like, make enough tea to last through the session. So I'm going to steep probably about 2 regular pots or whatever will fit in my nice thermos here. And then I'll be ready to go. So that is probably 5 minutes before we start, something like that. I can roll in my chair to the bathroom. I think that would be a violation of the rules. OBS ships with a countdown script. Yeah, okay, here's the deal. Because this is the first time we're doing this on stream, I really don't want to get into anything that might be a derail, right? I think for the next one, I could, like, you know, get that going. Yeah. Actually, you know what? While the tea is steeping, I'll eat a quick salad so that I make sure I have leaf energy, which I think is one of the 4 mana types in Magic, or 5 mana types. Why is it called a crank session? Because you just turn the crank, and then at the end, your program is done, and then you can retire because you don't have anything else to do. That'll drive chat insane if you spot a bug. That may happen. You may see me do the dumbest thing in the first minute and then spend 2 hours, 59 minutes trying to debug it while you're sitting there the whole time going, it's right there. That could be the outcome. Yeah, I could ask Casey for the handmade hero timer. That is true. I'm going to have snow mints as well. That's going to be so good. All right, tea batch 1 is steeping. We're probably going to have to do again. Should I unban Insobot for this? I guess so, because I won't be here. But Insobot's probably broken, because I don't think it recovers from bans correctly. So I have to say, do I have to say, or check about page on mobile? Is that what? Why was it banned? Just because. So the problem with Insobot is people keep adding helpful responses, right? Like, hey, when people say this thing, reply with this thing. When people say that thing, reply with that thing. But people tend to not be super careful about avoiding false positives when they do that. And so over time, you just end up in a place where like 80% of what Insobot says is an incorrect pattern match. And it's just noise at that point, right? And I just got annoyed at that yesterday. So that's all. Like, you know, there's a thing that says, for example, don't ask questions about other programming languages, which would be fine if it only ever triggered when somebody asked a question about a programming language, right? But it actually triggers all the time. And it's not like you could easily search for question marks or something because nobody punctuates their sentences on the internet these days. So like you would have to do some actual sentiment analysis and some like semantic analysis to like understand if it's a question. And that's not that easy to do for like a one-off message, you know what I mean? Yeah, the language one, it's weird. It's like, I mean, I think that in principle is a good message to have, right? It's just I don't know how to do it. I don't know how to do it in a good way. Okay, we are on tea steeping number 2. We are nearing the end of the pre-stream. We sure had good times with Sydney past couple days. Okay. All right. Let me clear off some unnecessary things from the area. Honey Bear will probably not make an appearance. Okay, I have a lot of tea that I think I made a little too strong. I think I'm just about ready to go. Yeah, the other thing about Insobot is if every Insobot reply is like, don't do that because the streamer will get mad. It just sounds like being scolded all the time or like stepping on eggshells all the time. Now, I may actually get annoyed if people do say that, but I don't know. Like, it's not a panacea. All right, everybody. Here we go. We are turning off this. We are turning on this very important text, which will be on the screen for the entire session. Actually, no. Actually, no. If it gave links to things like what a bike shed or a cargo cult is, it may take up way less space. That could be. I think it's worth thinking about. All right, everybody. I am now turning off my chat monitor, which hopefully doesn't hose my main monitor because it's Windows. Let's see. It might like... Okay, we'll see what happens. I might have to turn it on briefly if like windows disappear onto that one or something. Everything, I'm just doing a quick test to make sure everything is fine. Wait, did I, hold on. I haven't started the timer yet. I'm turning it back on for a second. I'm making sure, okay, yeah. I did, I just wanted to make sure I turned off the, this is not the stream thing. All right, really bye. Really bye. And, let's make sure we can actually run the compiler. Actually, I'm going to close this chat window just so I have... In fact, you know what? Here's what we're going to do. I'm going to probably want to look up stuff on the internet, but we'll just leave that on the main monitor. So I know nothing about the world of Twitch now. I have no web browser open except this. All right. Cool. Here we go. So I'm just getting set up. I need to make the compiler recognize what these are because anything marked as intrinsic needs to have a definition, right? So I'm going to look for, like, for example, byte swap. Oh, it's not there. Okay. Okay, bytecode. Wait, what? Really? Okay. Cool. I guess we just do it by string in here, which will not scale, but it's fine for now. So right now, the way that we do intrinsics is we just store them as bytecode most of the time. There's not necessarily a one-to-one mapping, but this probably also does not scale. We'll see. It's maybe why, in the long run, inline assembly is a better option. Okay, so I need to type check this argument because the thing was polymorphic. And so yeah, we're just going to put an incomplete. Okay, I need to make the instructions for this. Okay, let's see if that compiles. While that's happening, we can start looking at making these actually do a thing. Which is again going to be annoying because we have to do it 3 times. We have to do it in the bytecode interpreter, which is what I'm doing now. We have to do it in LLVM backend and the x64 backend. Okay. And when we use intrinsics here, we have to do it for at least for Linux and Windows right now, which is what's going on here. Okay. Oh yeah, we had no result register. Yeah, that's fine. These functions all return 1 argument, so case value 1 already used. Wait, where? Oh. Wait, what? What do you mean case value 1, bro? Oh, there. Ah, I see. Wrong. Wrong. There's 2 underscores. Okay. Built-in 2 underscore built-in 2 underscore pop count. So many copy pasta errors. I'm just looking at the other intrinsics to make sure. Yeah, it's fine. Seems fine. That didn't work. Why not? Let's find out. First, let's read the thing. Pop Kint. Well, see what's going on. Oh, because this is, guys, I'm stupid. We didn't do the machine code yet, guys. This is for compile time execution right now. Okay, there we go. It's 16. That's what it should be. Okay. How about, Great. It's working. Let's do that for all the sizes. Seems about right that that's 40 bits. I don't actually know how many bits it is. Let's claim it's 40 though. So now let's just assume these are correct and the beta testers will complain if they are not. This will also become our test program later. Actually, let's do this. What's the best way to do this? Let's do this. Make sure it's U32. Right, so we're just going to do this. All right. Intentionally getting that wrong. Okay, so this is already a test of this feature. Now I have a choice. I could do pop count in the rest of the back ends, or I could do bit scan here and then just move on to the other back ends. And I'm going to do the latter. I'm going to do bit scan here. Oh my gosh, the tea is too hot. The tea is too hot. Oh man, thermoses are really high technology. Okay. Yes. All right. So I mean, I could do the same thing. we could actually eventually combine, do bit scan and pop count on the same number, right? And pass what all the answers should be. That's probably what we'll do. First, we'll do it separately. Okay, bit scan test. I don't know, we'll put the second parameter later. All right. Great. Got to go back here. Bit scan. Options 1 for reverse, option 0 for forward. I don't know if this is the best way to store it, but it is what it is. Okay. And we're not testing Linux right now, so we'll test this later on. We're just doing all Windows first. Intrinsic. What's it called? Oh, bit scan. All right. I don't know, dude. I don't know how to find anything. Bit and oh, there we go. There's no 16-bit. We might have to make that up. Okay. Okay. So I don't even remember, is forward from the least significant to the most significant? Like, this thing doesn't even bother to tell you anything. Oh, LSB, there we go. I skipped it. LSB to MSB is forward. Great. So for forward, I guess it returns the bit number. So if we cast up for a reverse, we actually don't care. Okay, the problem is this is a giant pain in the butt, because if it's a signed, no, we can always treat it as unsigned. Like if it's a signed 8-bit number, the highest, if it's negative, the result will be 7, right? Because the high bit will be set. You don't want a result higher than 7, so you don't actually want to sign extend. So you want to treat it as unsigned, even if it's signed. We're going to have to test this. But I think that's right. I believe that's true. And then, what is the what is the GCC intrinsic? Built-in FFSLL. So the LL is the type. Find first set, I guess. Is there FLS? No. Find first set. Turns 1 plus the index of the least significant right. Okay, I guess that's standard, the 1 plus, because you want to know if there's no 0 bits. Okay. So I'm going to search for the phrase most significant 1 bit. What? Do they not have? Oh, I forgot that the pop counts are different. By the way, hold on. Built-in pop count L unsigned long. And then LL Cool J right there. Okay. That was good. We almost made a mistake there. We probably still made a mistake there. Okay. FFS. I don't know how to find the opposite direction. Maybe you're supposed to do something else. Is there a built-in F? Built-in F. P classify. FFS, FFSL. FABs. Oh, come on, guys. You can't. Why? Do they want me to not? No, that wouldn't work. Okay. So this guy is doing bit scan reverse. Okay, this guy is just implementing it himself. That's not great. This is productivity killing. Like, web searches didn't used to be this hard to find things. Okay. Count leading zeros. We should probably do a count leading zeros. Okay, wait. So we do count leading zeros and then do a minus. Right? So if it's 32 bits, the top bit is set. We'll get 32. No. Oh, God. I should just get Hacker's Delight out because there's a page. It just says how to do everything in terms of everything else. Okay, so let's do 8 bits. 1, 1, 1, 1, 1, 1, 1, 1. Count leading zeros of this is probably 0. Right, which means bit scan reverse should be 8. Right? And if count leading zeros is 1, it should be 7. So yeah, it's 8. It's just 8 minus the CLZ, right? Except that the CLZ, see, this is really annoying because we have to compensate for the fact that the word's bigger now, because CLZ is going to return you extra zeros that have to be subtracted off. All right. What jerks? If x is 0, the result is undefined. Dude, this is so lame. This is so lame. Everybody wonders why software on Linux is bad. It's because this is the reason. It's because of built-in CLZ. All right. Now everybody in chat is going, oh my God, no, just do this other thing. But I don't know what that other thing is. So I have to actually do this. So I have to do a giant mess for every size. I have to say temp is built-in CLZ. Okay, well, if value, because GCC intrinsics are super dumb, this is undefined for 0 for some reason. Why would you have a thing that counts bits and it's undefined for some input? Like, that's the worst. Let me find out if the actual x64 instruction, because that would be the motivation for that, but then just make it work. This is impossible to find anything. All right. Oh, it's not called leading zeros. LZ count. That's why. We'll produce the operand size when the input operand is 0. Counts the number of leading most significant 0 bits in the source operand, returning the result into a destination. Like, guys, get your act together. Okay. Anyway. All right. So this is going to be a disaster either way, but whatever. We might want to do a CLZ intrinsic later, but we're doing bit scan because that's what specifically was requested from people. Okay. So God, that's so stupid. All right. The whole point of using an intrinsic is so that it's fast if it can be, and like, so doing this is like crazy. All right. Built-in CLZ. It's fine. We make it work. If there's a better thing that we could do later, we could switch it later. But for now, Linux, Mr. Frederick Linux is making us crawl through a sewer. So we have to crawl through the sewer. If value Hold on. Okay. So we do count leading zeros of I guess, or just value, right? So that's going to be, is that a 16-bit? Is that a 32-bit? Unsigned int, unsigned long, which is going to be the same, and unsigned long. All right, so we're just going to say, like, who even knows what that means, dude? Okay. So, result is then going to be temp minus 24, or no, this is how many zeros now, because we have to subtract off the 24 bits on the top, and then we have to subtract the word size from that, right? That doesn't sound right. Maybe it's fine. All right. Let's just spam this for all of these. We're not going to test this again till later, thank God, because that's the Linux section. All right. Lines of code of the compiler is certainly going to go up. So that's 16. And then this is 16 minus temp minus 16, which actually, you know, right, this is 32 minus temp minus 0. And then wait. Guys, I'm so confused right now. Okay, first of all, this is if not reverse. This is a forward. So, okay, we'll fix it in post. Hold on. Size 8 is 64 minus. This is LL Cool J. This is just temp, right? I don't even know. Something like that. Okay. So these are not 8. These are 64, 32, uh, 16, and then 8. Okay, this was pasted from all the pop counts, so we've still got the pop counts here. Oh, we didn't delete this printf down here. That's great. Okay, great. What a mess. What an unholy mess. All right. So this is if not reverse. Okay. FFS. FFS is the right acronym for what's going on right now. Okay. Otherwise, we take the 8. We count leading zeros, which is 32-bit. So we subtract 24, and then we go 8 minus that. All right. We're just going to test this because I probably got confused on these numbers. Okay, so for the Windows version, which actually has what we want, we do input.use16 and 16, right? And 32, 32, and what's the, got so many of this page. We're going to leave that page up. Bit scan forward 64. Okay. So maybe not. Oh, right. Whoops. Bit scan reverse. Mask. They didn't care who I was till I put on the mask. What is the mask? Oh, wait, this is a masked operation. I didn't realize. Is that true for bit scan forward? Yeah, I was staring right at the thing and there's a mask right there. Okay. We're just not going to do a mask right now. Or are we? Let's just get it working without the mask and then maybe we'll add it if we want it. Where's our... Okay. BSF. Bit scan forward. This is not masked, right? I mean, it's weird to do the mask in the intrinsic because you would just and the value, right? That's kind of, maybe that's like exactly what they wanted in Windows or something. Okay. So bit scan forward, bit scan reverse, and we're just going to mask. Wear your mask, even if you're running. Even if you're having a baby. Okay, something like that, right? Wait, it's a point. Why don't I read documentation? This is supposed to be No, wait, no, I'm stupid. The mask is the actual input value. Okay, wait, it's not. Okay, this is actually the return value with the bit position. Why don't we just make it exactly like other... Okay, this is a weird thing. We could make it exactly like pop count. Wait, what did pop count do? Pop count, it was like 1 plus for... Wait, no. I'm so confused right now. Like, this has been made more confusing than it needs to be. Bit position of the first bit set. Okay, so, all right, let's undo this. This was not what I thought that was strange, but I did it anyway. Okay, so this is right, unsigned log. Oh, no. See, I'm doing this here and here. Okay, hold on. What do we want to return to the people? Do we want to return to values? Let's go back to what the GCC one is. Returns 1 plus. Okay, that's the 1 plus. Like, I don't know if people would find the 1 plus objectionable. We're just going to implement it that way for now. And, yeah. So this was, non-zero otherwise, is non-zero. Okay. That's an unsigned char. All right, so I'm glad that the Windows documentation doesn't use the stupid macro types everywhere now. Like, these are actual types. That's great. Okay. I messed up so many things. The Linux one is totally broken. Hold on. Focus on the Windows. Focus on the Windows. Okay. So, I think we're doing this. I don't know. We'll find out in post. Okay, so all sorts of stupid stuff here that I messed up. So this is going to be temp, right? Wait, no. Oh, no. Never mind. That's fine. Let's tell people. Maybe the 1 plus is not the most efficient form of the intrinsic, but that is changeable later. Wow, look how much longer bit scan is taking than pop count did. Okay, So we do our FFS. Otherwise, all right, maybe I didn't mess. I don't know. We'll see. Okay. Okay. It's going to be a disaster. All right. Forward 5, reverse 32. That is the correct answer. Lol. All right. Okay, bit scan, forward 5, reverse 32. Bit scan, forward 1, reverse 16. That's also correct. Bit scan, forward 1, reverse 5. 1, 2, 3, 4, 5. Yeah? No. Shouldn't that be 6? Because it should be 1 plus the highest. 5. Oh, no, because it's bit 4 if you count starting at 0. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Right answer. Forward 2, yeah, because 1 isn't set, or that would be F. Reverse 64. Yeah, okay. Look, we did it, guys. Now, do I do better tests? Yeah, we needed to do negative numbers. S8 of minus 1. And that should be 8, right? For pop count. Forward 1, reverse 8. Count is 8. Whoops. Okay, so let's put some answer checking in our bit scan as well. And you know what? This is like unnecessary. Okay. We just built it out that way. That's how it ended up, but there we go. Okay. Now, I don't know. Dude, we certainly could add a lot more tests here. I think that comes later. I think what we're aiming for right now is plausibly that these basically work, and then we'll hunt down like exhaustive error checking later. So 532, right? 1's 16. And if these answers are wrong for some reason, we'll fix it in post. Okay. 1/8, 1/16, 132, and 164. Oh, multi-test. Great. Ship it. Next. Well, if we run the actual compiled program, let's say, for example, with x64 backend, it's going to complain. It doesn't like that. So let's go there. All right. Pop count. So for now, since we don't have bit scan, we're just not gonna, we're gonna take that out of our test momentarily. Multi-test is not gonna test bit scans. It's just gonna test pop counts. Okay, we don't care about built-ins, intrinsics, we care about x64. Number of bits set to 1 in the second. I haven't had any chocolate yet. In the second operand, it returns the count in the first operand. Okay. $16, 32, and 64. We can be lazy balls right now and just always do 64 for pop count. It doesn't matter. Actually, maybe we'll do that. Since I'm having a good time right now, maybe we'll just do it, but we'll do it for 64 first. We'll do see what I'm doing here with this auto reg equals RAX. Eventually, we're going to want to do like a register allocation scheme. Right now, it's just hard coded. So we're pretending like we got this register from something that gives out registers. So we do that. Oh, does this sign extend? Move extend. Yeah. Okay. Oh, but we don't want to extend. We don't want to extend for pop count. Oh, but okay. Yeah. So okay. False. Okay. Next, we're going to go OX F3, which is the leading byte, and then Rex W and OF OX B8. And then here, I never remember what /R means because I only do this once every billion years. Let's see what it was for like byte swap, right? See, this isn't a /R. I don't remember how to make /R. I need an instruction with a /R. I think it's like this. I think it's, I'm just going to try this. And that, oh, that's the source register, right? So it's reg. Hold on. R64, RM64. What? Why is there two? Where do I put the other? Oh, both, they both go in there. That's maybe what /R is. This is what the problem with only doing this like once a year at the most. So we have mod R and M. And I don't remember what R and M are. I'm going to pretend it's like this. So we might have to look at disassembly here. In the second operand, and returns the count in the first operand. We're just going to do RAX for both. Well, let's make them different. Normally, I would just put it right back into A. Let's put C. For some reason, A is the first register and C is the second register. Why? I don't know. Okay. Maybe it's that. I don't know. We'll look at the thing. F3, X, Rex W, OF, B8. Okay. Sure. I'd buy that for $1. BC Reg, undeclared identifier. Yeah. That's just this. Oh, wait, no, BC Reg. That's not this. That is, let's just use this. Hopefully it's not a disaster. All right. And we crash. So, certainly we didn't get it right. And Remedy crashes on our x64 debug output, so we get to use Visual Studio, which last I checked didn't. Let's just try running. See what happens. Access violation reading location FO. Oh, so it thinks that's memory. Oh, because it's RM. We need to tell it it's a register operand and not a memory operand, which I think is the 3. I think that's a 3. Let's see. Wait, I got too many compilers. Too many compilers. Okay. So, this is the wrong answer, but it might be that I have the order swapped, because 58 is kind of reasonable. $493. No, that was not the answer. Okay. So what we will do is look at the generated assembly and see what it looks like. Yeah. Okay, and it will be a mess because it is very unoptimized. Debug, Windows, disassembly. All right. Pop count, RAX, RC. That's just backwards. I think that's the dest register, right? So we do want them backwards, but that wasn't the only problem. Okay, pop count, RA. Wait, what? Hold on. Did I just double reverse Immelman myself? Hold on. Okay. RAX. What is going on? Did I not recompile last? Hold on. Dest, reg. Rebuilding the compiler. Step 1. Rebuilding the test program. Step 2. Running the test program. Step 3. Okay, this is what I must have double reverse triple lutzed myself. Okay, so we pop count from A into C. That's fine, I guess. So well, and then I destroy A all of a sudden. Wait, I'm doing an extra move. Did I copy pasta this? Hold on. Oh, no, we just don't write the result out, guys. So you kind of, if you want to succeed in the game industry, after you do the pop count, you should store the result in the target register. Otherwise, it will not be correct. And now it is correct. Do you see? Okay, we're going to be fancy and do a 32-bit pop count if it's 32 bits. Because right now we are always outputting 64 bits. Okay. How do we do that? We say if okay, how do we do a 32-bit? There's obviously no Rex W in there. So 32, we could even do 16. Let's do 32 first. So F3OF B8. Yeah, it's the same thing with just no Rex W. Whoops, sorry. All right, and actually, let's do this. I mean, you know, you got to have the 16-bit You got to do the 16 bits. All right, so 16 bits was same. Oh, but it needs the 16-bit prefix. Oh, screw that. That's not worth it. Because that just makes the instruction bigger to make it 16 bits. There's like a prefix. Let me see. Where is it? Op 16-bit. OX66 is how you say this is actually a 16-bit instruction. So like, unless you thought that that would result in a CPU savings, I'm not sure why you would bother. And I doubt that there's a noticeable savings. All right, let's see if I broke something. Rebuild compiler, step 1. Rebuild test program, step 2. Run test program, step 3, and it passes. Oh. So that's pop count. Now we need bit scans. Easy peasy. Bytecode intrinsic bit scan. We're just going to copy this whole thing to start. Look how much easier that was, by the way. So when people talk about programming higher level systems or something, look at how much code this was. Okay, this was the code to do pop count for x64 assembly language or machine language, right? This was the code to do it on Windows and Linux just to run on x64 CPUs. How many lines? Oh, that's BitScan. Okay, hold on. Pop count wasn't as bad as BitScan, but we're going to get to BitScan. This is like, okay, it starts at 2409 and it goes till 24. It's 50 lines. This is 2774 to 2796. It's 22 lines. I don't want to know how much worse BitScan is going to be. But you see what I'm saying? Like, somehow going higher level a lot of the time doesn't make the problem easier. Now, it helps that what we are doing does map directly to a CPU instruction, but still, like, this is a phenomenon that I see a lot. Okay. Pop count, bit scan. Oh yeah, I was just gonna copy this whole thing, and we're gonna make that be bit scan, because we kind of want to get a result register. Yeah, we don't really want to sign extend either, I guess. Okay, so let's figure this out. BSF, the Rocker's Revenge. Okay, OFBC/R and RexW OFBC/R. Okay, so we're just going to go. We're just going to do that. That's RexW and then F3, or sorry, 0F BC/R. 0F BC/R. Okay, now, what if it's reversed? If it's reversed, it's OFBD/R. That could be faster, whatever. So there we go. A lot of x64 instructions are this way, right? There's a 1-bit difference. Okay. So that gives us forward or reverse. This gives us 64 or 32-bit. And then, I mean, I guess that's all that we want. I feel like I'm leaving a step out about adding or subtracting something, right? Let's just see what this does for us. Oh, we don't have bit scans enabled. This probably won't work, but let's see. Yeah. Oh, we need to add one to the result. How do we do that efficiently? Because we want the result to be 0. I need to test the A register against 0 and add if it's non-zero. I need, there's got to be a trick for that, right? Like getting something into the carry bit, right? Okay. If and only if RAX is non-zero. I'm not enough of an assembly dude. So anyway, we can subtract with carry would be the second part of that. Sub S. I don't remember what that is. Des source size. So I could go zero register RBX and then sub S output. The destination is going to be RCX. The source is wait, that's not a subtract. No, it is. Is this a minus equals? RCX minus equals RBX with the size. Okay. So we're subtract 0. Wait, we want to add. We want to add 0, which will add 1 if the carry bit is set. Okay. So test, right? Test might give us the opposite of what we want, right? If you go like test RAX, looking for the word test is a nightmare. Oh God, look at all the V test. This is a time when getting help from someone in chat who knows the answer to this would be really helpful. So test, and sets the SF and 0 flag and all that. Okay, sign flag, 0 flag, and PF. So 0 flag. Okay, I want to increment if 0 flag, x64 increment if ZF. I mean, I could use a jump, but I really don't want to do it. Why am I getting school lectures? I mean, I could do it. I could make a jump. Ugh. I know there's a way to do it. I've done it before. I've done it before. ZF. Zero flag. Set Z. Wait. Okay, hold on. Set Z. It's not called set Z. Set byte on condition. I don't want to set. This is so simple if I just knew the right thing. Set E. Set byte if equal. I don't want to set though. I want to add, right? Add CC, right? There's an add CC. No. Writes carry flag. Oh, but it also reads the carry flag. We don't want the carry flag. I'm sure people in chat are just like, oh, dummy, do the thing. Just do the thing. I could just move on from here and then just ask chat at the end. That might be the most expedient thing to do. Zero flag. Come on, give me more related instructions. Like, if I could just scan. I just want this one thing. I could do a jump. So it's got to be add with carry maybe instead of... So how do I generate a carry? How do I generate a carry if 0? Like, I don't know that either. I don't know. I'm not finding it. It's taking too long to find a simple thing. So you know what? I'm going to call this done for now, even though it doesn't actually work, because literally it's correct, except I need to... Oh, no, you know what? We're going to do it. Screw it. Okay. We're going to go. I'm not going to call it done. We're going to be really gross. Wait, what is set NZ? What is set NZ? That sounds good. Oh, that's if... Okay, that's just another set. We don't... All right, let's do that. Let's do like a set A situation. Set A... Set CC. Okay, we're going to go. So set if 0 flag is, so set E. We don't have a set E, but we're going to add one right now. OF94. Okay. So we're going to go test. Do we not have test? Okay, whatever. We're going to test. Okay. Well, except set byte if equal. I guess it leaves the rest of it. No, it's just called 0. Okay, so we're going to 0 the B register. We're going to set it. We're going to do this just so we don't mess with the flags. Oh, we already had that. We're going to add. We just want to add now. Add 64. And then store. Who knows, guys? Okay, that was less messy than I thought. Okay, wait, though. Do we want test? Hold on. I don't feel like test is quite the right thing. Test. Computes the bitwise logical and. Okay, so 0 flag is if no bits are and. I don't know. I don't know, guys. Oh, we don't have test. R64. We're just going to do an R64 version. .bytes rex w 85 mod rm 3 rx. All right. Okay. It didn't do it. We still have the same answer, 431. Why? Test RAX against RAX. Set E. I mean, we could just step through that, right? So, bit scan test. Okay, bit scan forward. How do I step? I guess if I just have focus here. Bit scan forward. That's got the right answer. Okay, B is 0. How do I check the flags, registers? Oh my God, this is the worst window in the world. How do I get like flags, registers? Like, dude, is that EFL? Like, how do I? Can I just say ZF? Nope. So I can't actually tell what's going on. Thanks, Visual Studio. I don't want register values. Ah, that's what I want right there. Except I don't. Those are weird. Right clicking. Oh. Flags. What are these? ZR. Is it ZR? That's not the standard name. All right. Test. Okay. I guess I'm reading this wrong. Okay. I should actually read this thing down here. PF, CF. If temp equals 0, then 0 flag is 1. RIP. Why is it 0? We did test RX. RX is non-zero. 0 flag, if that is 0 flag, I don't see what else would be 0 flag. It should be 1. That's some bull pucky. So then the B register is not going to get anything, right? And then we're going to add, and so C is not going to change, and ripperoonie. So I think false advertising. Is any good with any known non-zero. Wait. This is weird. I just want to know. I just want to use the 0 flag. It's so weird how I keep getting the same couple of articles as results. The point of test, EAX. sets the 0 flag when the result of the AND operation is 0. That's what I'm saying. Guys, I don't... So first, why is this ZR and not ZF? What even is that? Flags. 0, ZR. What? I don't get it. Test this against this. It's non-zero. Oh, so the 0 flag is 1 if it's 0? Maybe I'm thinking about it backwards. We could find this out. I think my brain is backwards. We could find this out by adding a test case that we should have had anyway of, I don't know, let's say U32 0. The pop count of that should be 0, and bit scan forward should be 0, and reverse should be 0 as well, right? Who knows if that'll even work? Okay, that worked for there. Great. We got a giant mess in x64. So that's confusing. But we can actually step through that and see what happens. Right. Okay. So A is now 0. Test it. 0 flag is okay. My brain was backwards in everything that I was reading then. So instead of, I want to reverse the condition. Instead of set E, I want like set B or something like that. Okay, so now B is going to get a 1, which we don't want. Okay. Now RCX, though, the problem is RCX got a huge number. So I guess this doesn't... Maybe that's why the GCC is undefined. Hold on. Let's go back and read about bit scan. I thought it said if it was 0, it was defined. But... okay. Des is undefined. Whoops. Okay. This is fine. Oh, this is better though. Wait, what am I doing all the... Guys, if you actually... I'm not good at reading things. I am not good at reading things. If you actually read things, sometimes it saves you trouble. This... Now, the benefit of doing things the way that I do them is I often don't rat hole on stuff and I'm very productive. But sometimes I take the penalty of this approach, as I did here. Look, the bit scan tells you if it was 0. Jerk. Okay. Get rid of all this. We do the bit scan. Whoops. Now, if it was 0... So if it was 0, we want to put 0 in the target register. We could use a branch for this. Or we could do the kind of thing we were doing up here. Let's try to do the kind of thing we were doing up here and do it branchless. So we do the bytes. We do the bit scan. Okay. Now 0 flag is set. Okay. So I want to clear if ZF of dest, or increment if not ZF dest. That's what I want to do. So we do this. Okay, can we do like a clear? There is no like clear, so that's the problem. Do I do a, I'm just going to do a branch, guys. We'll fix it in post. Okay, what is the definition of above? No. Equal. JE, right? I don't have a JE. Oh, is equal. 74074, yeah. Okay. So we're going to do this. We're going to do this. We're going to go branch A byte is JCC. So jump if equal to 0 to somewhere. No, let's do non-zero. Okay, so that's 7.5. And then here we say 0 RCX if carry flag, or if 0 flag is 0, right? Jump if equals it. Wait, yeah. Okay. This is not what we want. We want the 7.5. Jump if not. Okay, great. So we 0 RCX. Now, how do I do this next part without another jump? So I want to increment if 0 flag is not set, and that would be the target of this jump. I guess we'll do this, right? Okay, we're just going to do 2 branches because that's what we're doing. This is super stupid. Later in chat, we can talk about how to do it better. So we do a relative jump. Post branch B, right? And then yeah. So this just fills in whatever this was. So we jump down to here. We increment if not ZF, and then hold on. Wait, what? That's not right. Oh, I guess it is. Okay, okay, this is just increment now. Inc. Let's just look it up. Inc. Not Fink. Inc. Inc. Just going to do 64-bit Rex WFF. Inc RCX. So output.bytes Rex W FF and mod RM3 RCX0, I think. Something like that. Okay. So I hate doing these I need to make a better way to do these branches. Okay, I'm so confused. So we do the thing. We jump, if non-zero, we clear the thing. We jump to the bottom. This is going to be all messed up. We fill in the branch A byte with whatever is here. This seems weird. I don't know why that's not +1, but it worked elsewhere, so whatever. We ink this. This is such a disaster. And then we're done. This is not right, but let's just see what happens. The moral of the story is when you make your CPU, have it have good behavior for these things. All right. Wait, this is not new. Wait, what? Oh, because we didn't recompile the thing. I was looking at that. I'm like, that's the old code. All right. Bit scan forward. C3. Okay, I actually accidentally decremented instead of incremented. So that's wrong. And this is all messed up. Okay, hold on. Why did I... Increment is FF Rex W FF 0. Rex W FF. Maybe that's that. I don't know. I don't know anything about x64, guys. That's still decrement. Oh, no, because I didn't recompile. Still decrement, dudes. What? I know I have... I must have done an increment, right? Inc64. FF30 up. Oh. Yeah. Okay. We'll use that thing anyway, but I needed to put the RCX there instead of there. Okay, fine. We are so fine. Okay. B13. So it does look like we hit the right address. B15. No. This second branch is 1 byte off. That was bad news bears. All right. Okay, so bit scan. If it's 0, clear C. Otherwise, and this is stupid because we're clearing C and then storing C. We could just store 0 in the target register and then jump to the end. It doesn't matter. But anyway, and then jump to 9C6, which is here. Otherwise, we increment. Okay, well, I don't know. GG's. So that's 2 platforms out of 3. I kind of want to go to the bathroom, but I feel like we have at least an hour left. So I'm going to hold it. Okay. There is a way better way to do this. Maybe a C move. Like instead of this branch, maybe I could do a C move. I'm just going to write down better bit scan question mark. All right, platform number 3, LVM. We got to do pop count. And this one might be the nightmare. This one might be the one that kills me. I don't know. Let's just see. Pop count. Okay, we don't really want a size exception here, whatever we're doing, because... All right. Let's have some sugar. Let's have a snowman. I'm very happy. This, I had no reason to believe that I would even get the X64 done this far. I'm sure the documentation will be wonderful. Okay, great, great. The value to be counted. Counts the ones. Okay, no singularities. That's good. So the thing I never did was type check the arguments to these intrinsics to make sure they're integers, because they're polymorphic intrinsics. We can do that later. Okay, intrinsic : CNCT pop. Okay. We're going to create a call, CT pop. There is no cast type here. Wait, what? Oh, that was for floats. I mean, maybe this will be simple. CT pop. I mean, maybe. I don't know. I don't know anything. Oh, let's redisable in our test our bit scan. Oh, actually, that's not even good enough because we have to make it not complain of unknown instructions. So we just need to say bit scan here. Break and nada. Okay, so So that was x64. That's LLVM. It didn't crash. It didn't like it though. The 1 byte argument is unhappy. Why would that be? Because it says any size. Does LLVM a liar? It says any size. Counts the number of bits set in a value. Well, if it's not going to like 1 byte, then wait. No, that's not what we want. We want value bitcast. Dude, I hate casting in LLVM. It's so gnarly. How do I just cast up to an integer? It's not create cast. These are all pointer casts everywhere. Because every single time it's a pointer cast. Okay, cast, open paren. Create number cast. Yes. Okay. Create. Oh, ZX. Yeah, okay, this is good. This is good. Value equals IR builder. Create ZX value, comma, and then dist is I32. Okay, that actually makes sense. Unlike a lot of things in LLVM, this line of code actually makes a lot of sense and is not egregiously horribly long compared to what it could be. Now watch it not work, of course. But, oh yeah. Oh, that's totally... Never mind what I said. Wait. To LLVM load inst. How is the result of a create load not a load inst? Oh wait, this is icy. This is a load inst. This is okay. Never mind. Whoops. Right? That was just auto biting me. What I was saying was the opposite of what it was. Okay. Well, we got further now. So why is that? The LLVM docs claim that the CT pop intrinsic works on all sizes, but in practice it was failing on 8 bits. So I extend if 8 bits. Okay, what is it now? Cafe Babe food face is 40. Do we print the one that we fail on? Yeah. Just for avoidance of doubt. Answer 0. Cafe Babe Food Face was 0. I don't get it, guys. Why is it 16 and 32 bits are the right answer? 64 bits. Wait, where are we getting the 40 from? Wait. Oh, the size of the result is wrong, guys. LLVM is giving us a result type, because when we print it, it actually comes out. Or when we print it here, it's like stomping the correct answer. I don't frickin' know, dude. Hold on. I bet this is going to be fine. And then this is going to be not fine. Oh, no, except that changed the stack, so now it works. Okay, but this is actually the problem, is that this intrinsic is giving us something that is 64-bit potentially. Yes. Why it's doing that, I don't know. It doesn't seem like a good choice to me. But we want a number cast at the end. Okay. Result. If so create, let me get rid of this. Create number cast. IR builder. Result. See, I don't want to use number flags, though. Well, I guess I will. So the number flags are a thing that's in our, okay. Get number flags. I don't know if that's the right thing, but register A. And then the dest is helper I32. And that'll take care of truncating up or down. This is way too slow. So dest and okay. So there we go. Get number flags. Yes. Yeah, we can use that here. Great. Win. All right, so now we turn back on our bit scan. And that will not work, because we don't do anything for bit scans yet. Okay. So we have our intrinsics pages. bit scan. Wait, there is an LVM. Bits. What? Or are those somebody else's? How do I use these? This is not LLVM. This is, oh, it is LLVM. Bitscan forward should not be under if def read rand. Let me look at the patch. Okay. I don't see any. There's 3 commits here. I don't even know. Read rand. What? Where is the bit scan stuff? What is wrong with the internet? Why are these all the same commit? What am I even looking at? Bit scan built-ins. Oh, is it like comments? It must be this. I don't know. Okay. So how do I use this thing? So we're just going to do this, paste it down there, and we're not going to do this yet. Okay, so we bit scan. So we get a scan. We call that scan. We'll do the same cast. I honestly don't know where we're going to find this intrinsic though. Bit scan forward. Like, why are these? That's the Windows one. That's not the wrong place to look. See, these are not the same names as what you use. These are like, yeah, these are Clang. I don't know. I feel like I'm not going to be able to find this. There was that count leading zeros intrinsic. Let's just get the rest of it here. So I don't know. This is just not going to compile, right? Yes. C declaration. Enum ID unsigned. Okay. Great. That's helpful. Thank you. Thank you so much for that. I feel like we're about done with the time. No bit scan. Math extras. That's just for LLVM to use, though. Okay. We're in the land of tiny files. I don't know. I don't know what's going on here. Give up. Give up. I don't know. Okay. We did find on that page count leading zeros intrinsics. So I could try to use those. I just don't know why I can't use bit scan forward and whatever. Was this just never incorporated into LLVM? Oh, wait. Int x86. Do we use intrinsics like that? x86. Intrinsic x86 RDTSCP. Ah ha ha ha. No. Remove which re-implements their functionality using generic IR. What? Six 564. Built-in count trailing zero and count. Yeah. So like. This says underscore bit underscore scan. Do I just put the underscore? Like why is there? I don't know. Let's see. Nope. I'm just guessing. Like I have no way to know what to do. This is the usual LLVM situation. I have literally no way to know what to do. This is the last thing, too. This determines if we have full victory in the 3 hours. Well, I mean, any session when you get to eat sun chips is good. Now I've lost the previous page. Oh, bit manipulation. Okay. Okay. Bit manipulation intrinsics. See, I don't know what these names mean in terms of what I actually type in the actual API either, right? But anyway. Bit reverse, bit swap, CT pop. Okay, that was the same. CTLZ, CTTZ. So I guess we have to use these, which is, oh wait. What's Fisher? Oh, these are what we want. No, that's funnel shift. Wait, it was FFS. Was the other thing. Okay, so they don't give us actually I think we just have to implement things in terms of CTLZ and CTTZ. All right. Except I don't remember what leading and trailing zeros are. I mean, I need to swap those. I don't know. Okay. So these is going to give us wrong answers so far, but we'll see if we get answers. Okay, we at least have the intrinsics. That's good. Okay, we're going to have to read what these actually do and all that stuff. Okay. Bit scan of 0, forward 31, reverse 0. So, so count leading zeros, right? Is 0 undefined? Which should be false. Many algorithms are now predicated on avoiding zero value inputs. Great. Right? Like that. Okay. So this should still give us the same wrong answer. Oh boy. It didn't like that. Hold on. I1. What is an I1? LVM I1. How? Okay. LLVM double colon constant int. I don't even have I1. So now we have to say type get int one tie. Do I have a context? I don't even know. Helper arrow. Okay. We're just going to put it here. You know what? We have I1 now. Great. I hope I don't need that. All right. It probably defaults to 0 anyway, but I don't know that. Oh. Like, I just want to pass a 0. How, what? Okay, you know what? No. I tried. I give up. I give up. It's probably 0. Who knows? If 0 fails... 0 didn't fail, though, actually. So we're just not even going to go there. All right. Actually, it did just fail now. Wait, did we do the wrong... Oh, that was the wrong platform. Okay. Because I was expecting to see the number of leading zeros, and we got a different answer, and I was like, what? Okay, so this is actually the right answer. Well, I don't know under what definition it's 31. Like, why isn't it 32? LVM. Like, maybe that's the thing about 0 being undef. All right, I'm going to make it work for everything but 0 because I can't figure out how to pass a Boolean to LVM because my IQ is less than 500. All right. So forward 0, reverse 4. Now that's the opposite of what I think it's supposed to be. First of all, like forward, I don't know. Okay. So we want to go this way. All right. I bet there's just a bit scan intrinsic that if I knew what it was, it would do most of this. I don't know. I don't know, guys. Okay. Forward 4, reverse 0. So 4 leading zeros, or four zeros from the least significant bit, right? Reverse 0. Now, I guess I want to do the thing where I say compare the input with 0 and add 1 otherwise anyway, right? Yes. Okay. Well, here's where we do is something 0 or not 0. Because the thing is, we do need to do the increment. All right, so if it's 0, create icomp not e. I have a null value of load A, which is this, right? Wait. Load A is the create load. That's the value. It's fine. Up. Okay. So now I need an if statement with a frickin' then block and an else block. Create, and I don't remember. There's some really pointy head negative 300 IQ name for what this is in LLVM. And I don't remember what it is. I'm just okay. LLVM create conditional statement. Okay, condition create icomp, then basic block, else basic block. Create condbur, obviously. Create condbur. There we go. I knew I did it. So true block. Oh, come on. Mouse button hit the thing. I'm just trying to select text. Okay, so true block, false block. This guy doesn't believe that C types are what they are. That's fine. A lot of people don't. Oh, I need the frickin' context, guys. Oh, it's on helper. Okay, great. Good save. So true block, false block. We make the thing. I assume I can fill these out after. Who knows? So true block is going to have the stuff. I don't know how, like these creates are like putting them somewhere by default. We say set insert point, I see. True block. False block. And then how do we set the insert point back to where it was? I assume we say IR builder get insert point, and then IR builder set insert point. If we live in a reasonable universe, that is how you do it. But you know, oh yeah, we totally don't live in a reasonable universe. Okay, so that's a okay, so that's just it wants a reference. Oh, wait, we have a comment problem here. Yeah, I have a comment with a comment inside it, which you never should do that because that'll create a singularity that causes your programming language to implode. Load A, that's value, right? So again, basic block iterator. What the hell? Get in, oh God, not one of these. Get insert point. Oh wait, we want get insert block. Even though you call set insert point, you call get insert block. Okay. It doesn't say if it'll pick up where we left off or not. So this is completely a disaster. Actually, we probably don't need to do this anyway. Hold on. Anyway, okay. So for true block, we say load constant. I saw a 0 in here. 0.64. That's like Mega 64 after they get old. Okay, so in the true block, this is, oh wait, this is not equal to 0. So false block, but we want okay. So we could say register result arrow get type comma 0. Okay, and then we store the value. So we could make this work just for 0. In fact, we could do this for both. It's always, the result is always 0 now. Congratulations. This is just, oh yeah. How do I get the result pointer? Oh. This is just, we're like shadowing the thing. Okay, LLVM is very unhappy with this. Why, I do not know. It's like so unhappy. Zero is constant int. Okay, hold on. Before any of this condition or whatever, how about if we just do this? All right. We get the result pointer up here. See how long I'm spending doing nonsense? Like I'm not actually working on the problem I want to work on, which is just doing the bit scan, which is not that hard. All right, rip. I really have to go. All right. This is so frustrating, everybody. I'm going to keep going, but this is just, it's a waste of my life. The summer intern should be doing this. Like, why does this not even work? So up here, when we're doing pop count, we have, oh, are we the wrong type? Hold on. Register result get type. No, constant int 0. Like what? What's the problem? The result pointer is registers register result. Create store result in result pointer. I don't understand. Maybe we crashed for some other reason. Okay, hold on. Let's just do this. Assertion failed. Oh no, that's in our user code, right? Oh, well, wait. What? Why did we get 32? That doesn't... Guys, I'm so confused. Okay, so new rule for the future versions of this. We're going to have a restroom break at the 2-hour mark. Maybe we'll make them 4 hours with a break in the middle. I better drink some more water. Okay, very frustrated at, like, I should be done by now. Very annoying. What? We should be returning 0 for our result of bit scan at all times. So why are we getting forward 32, reverse 30? That's almost as if we ran an actual bit scan intrinsic. Did I fail to compile correctly? Debug. Debug. Oh, that's compiled time execution is broken now for some reason. That's weird. Okay. We could fix it in post. All right. Now we have the thing that we were trying to do. We're making a store inst. All right, guys. Even though according to the timer there's 18 minutes left, I am being distracted by the fact that I gotta go. So I'll be back and I'll add extra minutes to the timer to make up for a multiple of what I'm about to miss. Like, I could have held on there, but like at some point, if you're focusing on just staying in the game, it defeats the purpose of the exercise. All right. So what the hell's going on? We've got a lot of store insts. I don't know what they do. We're calling LLVM, we're crashing an LLVM value get context. Like what? We're just doing the same thing we always do. It probably doesn't like this 0, right? Okay, we know we want an I32, honestly. So let's just do that. It might not like the get type for some reason. Okay, great. Okay, we have zeros. That's fine. And we actually have progress, hopefully, because on this one, we have the right answer now. There we go. We get to our second test case. Okay, so I don't know. It's disturbing me that our compile time execution one started failing at some point. That might be a debug build thing. I don't know what that was. No, because maybe I accidentally deleted something. We'll take a look at it later. We're going to finish LLVM, hopefully in the time remaining. I mean, we'll continue over time otherwise, but I would like to. Okay, so we're going to do this one. And we're just going to change our 0 to this. So now it's an if block with a 0 in it either way, and then we store the result, right? So it should do exactly the same thing as we just did. Whoops. Yeah. Oh, just that. Okay. I kind of want to switch off the debug build because it's real slow in LLVM mode. Or it just infinitely loops for no reason. What? Really didn't like that. Okay. Oh, because we need to set the result. Wait. Oh, we need to restore the insert point anyway. Because later instructions are going to want this. Yeah, so this says get insert block and then does stuff. Okay. So let's try that. Yeah, the later instructions were like putting a bunch of other things in the wrong place probably. No, no good. I need a summer intern. Okay. Break all. Call stack. Mem to reg. It's like infinite looping in mem to reg for some reason. Okay. It doesn't like this condition. Something that I'm doing. Okay, what if I just do this part? We're going to set the insert block to the point. We're going to do this. We're just doing parts of... This is so stupid. Okay, so that doesn't make anything unhappy. So we have true block, false block. We could create this. Okay, how about that? Okay, that, it just barfs. So what? I mean, maybe I need to register the blocks in some way, some other way. See, all of this other stuff is for pre-existing blocks. So like, maybe I just can't do this. This is so stupid. I wish there was documentation. Okay, so we could set the parents on the blocks. Maybe that'll help. parent do I need to set all of these? What is next block? Okay. Like if I just felt like there was a place where I could just read in a reasonable way. I'm not working on the actual problem right now. This is the failure mode of all computers. Is like, I mean, I guess I'll try to read the documentation. Sometimes there's actual documentation, but usually there isn't, which is why I've sort of learned to stop. What is this called? Create conver. Okay. Like, these parentheses aren't even balanced. Like this tutorial is published on the LLVM page and nobody ever compiled it because the parentheses don't even balance. Like, am I wrong here? Am I lying? What's going on? So this is basically what I'm trying to do. We set insert point. We set insert point. Okay, hold on. It was this create. What is GCD? Is that like the outer scope? It's the function that we're in? Dude, I rage every time I see those box diagrams. All right. Context. Name. Function. Insert before. I don't want to insert before. Wait, what? Okay. None of this. Let's just. Maybe that. Let's just see where it crashes. Add predecessor. Yeah, so like it doesn't like successors or predecessors of the blocks or something. Baby rage. Baby rage. Baby rage. Baby rage. Baby rage. I wish I could work on the programming problem that I'm working on, that I made great progress on. Like is there an actual thing that has balanced parentheses that somebody ever actually compiled that does this? I assume maybe these are just wrong. Like someone did like a macro search and replace and left that in there. I gotta go some extra time because of my little sneak out. Dude, we should have had all of this done in the 3 hours, which was better than I thought I would do. But like LLVM just is a turd. Like, I don't know what to say. You can't, it's inscrutable. And nobody cares. Nobody really wants to put in effort to make it understandable. I don't know what's optional, what's mandatory. Like that other example didn't ever seem to set this. So we could try without that, but maybe we need that. I don't know. How am I supposed to find out? That other example was written for 5-year-old kids, it sounded like, from the language used in it. Okay. So we're creating a cond branch. Maybe it doesn't like that these blocks are empty. But then we put stuff in there before. Okay, let's put zeros in both of them and then put a 0 at the end as well. But I think it doesn't like that some pointers are not, like the predecessor and successor pointers are somehow not set on the blocks. Or whatever. Yeah, now it's just infinite looping. So I think like we need these. But like we break a basic block in two here, like we need to say jump out of the cond branch to the rest of the thing. That's what it might be confused by. All right. Well, the good thing is we're almost done. The bad thing is we just wasted an hour, 45 minutes on LLVM every time. It happens every time. But the good news is we're basically done, except, you know what? Let me table this for a second. And get that at least working, because for some reason the compile time execution didn't work, and I can at least deal with that, right? Okay. So let's go back to, like, this didn't somehow all of a sudden work, which was weird, but does it in the release compiler? Was that the difference? So it doesn't work in debug and it does work in release, which probably means uninitialized variable. Okay, scan equals 0 reverses BC options. I should just step through here, right? Oh no, got it right there. Bit scan. All right, so the first time it's actually going to be 0, right? Or that's going to be 0, so we don't care about this one. 0. Okay, so now this is going to be our FO, 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 FO. All right, so let's see what's happening. The size is 4. What is reverse? Reverse is uninitialized. BC options is uninitialized. Oh, yeah. It doesn't default to 0. Okay. That makes sense. BC options equals 0. 0 options means forward. Great. That's it. Hopefully. Wait. What? How did this ever work? How did this ever work at all? I don't even know, dude. Sometimes computers are crazy. All right. So we fixed that. Oh, in debug build though. Great. All right, I'm going to turn chat back on. We'll see if the stream is still going. We'll see if you guys have been laughing at me saying, just do this one thing in LLVM for like 2 hours. This has been very successful. So we added pop count, bit scan forward, and bit scan reverse. And we did that in compile time execution and the x64 backend. And we got pop count in the LLVM backend. We just haven't got quite bit scan yet. And then I'll try to do that for the rest of the night. And then we'll think about if we should have count leading and count trailing zeros separately from those intrinsics as well. How are we? Let me open my twitch.tv over here. What if there's like which.tv? There probably is. It's like Twitch for people who are into other things. Oh, we've got some hint coming in. The LLVM issue is that you weren't branching out of the two basic blocks into yet another new basic block. Okay, so I have to make one at the end? Can someone link me to a page that just shows how to do that? Because that example didn't really seem to be, maybe it did. I was very angry at that example, so I closed it, I think, but... example, this one. So create conver. I guess it doesn't show the whole source code. So like I can't, it's just pieces, right? That's not good. I guess this file lives somewhere. Tut2. But like create convert, it's returning. Yeah, this example just returns, which is why I didn't want to return, right? How's it going, everybody? Did we have big Fs during the 3 hours? So basically, they left big intrinsics or SIMD stuff. Yeah, I don't think we're going to do SIMD intrinsics this way. I think we'll probably do them with inline assembly or something like that, because this just doesn't scale to AVX or whatever. Oh, I missed the Lana raid? Okay, well, create burr instead of create con. Really? Create burr, not create browser history. Create burr, unconditional. Oh, you mean to jump out. Why does it link me here if I can't find create burr? Okay, so you're saying at the end, you're saying, so what you're saying is, do I have to do this parent thing or not? Okay, so I create a cond burr here. And then I do create burr to somewhere, right? And then I do that here as well. And then somewhere is after, right? And then do I just set the insert point there? Like that? If you just pass the parent, it will append to the end of the function. I think that's what I want, if I understand. Oh wait, no, I don't want to append to the end of the function. Because wait, what? And no insert point. But I don't want these to append anywhere, right? I want those to only exist inside here. And then the somewhere. I don't know. I don't know what that's going to do. Crash. That's what it's going to do. It's going to keep crashing. Basic block order doesn't affect execution flow, so you probably do want to append at the end. You mean this one? But you said and no insert point, and LLVM's always going to crash. That's just how it is. I don't know what to do about that. It's like they have all this C++ class template wrapping stuff around everything, and it won't even help you with a common mistake. Like, what is it for? What is all this stuff for? What are all these classes? Like, what is all this stuff for if it doesn't help you with mistakes in any way? This is actually a simple diagram compared to the other ones. It's also possible you have to tell the helper to use somewhere now instead of the old basic block. To use somewhere instead of the old basic block. I don't know how to do that. I don't know how to do anything here. The problem that I'm having is all the other create convers that we do in this program, we're using pre-existing basic blocks that are generated by the front end and then like transcripted over to LLVM. So they just kind of get created differently. And I could just try to replicate that in some way, but that seemed weird. Wait, did I not ever compile? What happened there? If anyone ever from the LLVM team ever applies for a job with me, I think they just don't get the job. I think it's a blanket no hire. I'm not sure. Maybe I should, entertain it, but try passing parent. Hey, it didn't crash. All right, so now we get 0 all the time, but that's no surprise because we do 0 in here and then another 0 out here. Okay. Let's put 1 in the, okay, so we're testing if it's not equal to 0. So we'll say 1 if it's not equal to 0 and 0 if it is equal to 0. Okay, that's working. Yay, it's working. All right, this is good. This is good. So now, instead of putting a 1 in here, we want to do this stuff, but this will still give us the wrong answer because we'll be off by 1. But that's fine. So we're going to take all this stuff. We're going to do that. So we pick the intrinsic. We cast the result. We store the result. And then we do our jump to somewhere. So that'll be off by 1. Result redefinition. It's just so funny how like a little piece of missing knowledge can just derail you forever. Okay. Count of this is 16. Bit scan is forward 0. Okay. So these are just off by 1, right? Wait. No, our bit scan reverse is totally the wrong thing. We did this. This is the same thing that we had to do in the GCC intrinsics, right? What did we do for bit scan? We did 8 minus and then 16 minus. This was so long ago. This was hours ago. It's like, I don't remember. This is why you just told me to use select last time. Oh, I didn't remember that at all. Like, I work on so many things that create select. Cond cast B limit. Is that like a question colon operator right there? So instead of all this stuff, but how do I, here's something I don't understand. These true and false values can't be IR builder creates, right? Because IR builder creates get appended to the instruction stream. So I can't do IR builder create some computation and then do this because it'll like be in the instruction stream and then happen, right? So I have to somehow do it without that. I don't understand that part. Hold on. No, I guess you do, because right here. Why? Okay, here's what I don't understand about LLVM globally speaking. And maybe this is just a hack in LLVM that solves this. Why, if I don't do this, if I only do this, does it put a left shift in the code right there, right? If I do this, then it doesn't put a left shift in the code and it puts it in the select. Like what? Or is that wrong? Select is like C move. You compute both sides. Oh. Oh, okay. That makes sense. That makes sense. You compute both sides. Well, one of those sides is very easy. Yeah, let's just do it. Okay. So we're going to go select true. Let's say if 0 result equals, and that's just going to be this thing. And that's if non-zero result is going to be something else. And then we're going to go IR builder create select cond if so we'll change this to an if create icomp EQ or something. Yeah. Okay. So all this block stuff is going to go in here. We create a select between 0 and whatever all this other stuff is. Right? So like this stuff. And then we do this. Result, not restore. Okay, right. If I had remembered that, that would have been much nicer than trying to do all this block and insert point stuff, for sure. Okay, so this is a different result here. Okay. If non-zero all right. Something like that. Oh yeah, I forgot this. Okay. Oh, okay. Forward 4, reverse 0, when it should be forward 5, reverse 32. So we just have to do the other operations. That we did before in the other thing, right? So we could delete all this. Delete all this. And significantly nicer. It might be fun to have an on-screen countdown timer. Yeah, I talked about that before the stream. I thought about it and I was like, yeah, that would be good. But I don't want to derail today by like trying to make that work and stuff. But I might borrow Casey's Handmade Hero or something. Let me turn off the text. So that was the first time I did one of those. I like that. I like that format. I think we're going to modify the format to be 2 hours, 5-minute break, and then 2 more hours. I think that's a good like crank session, you know. Is it correct to have both scan result on the SX and SX? I don't know what the SX is. Okay, however, I'm pretty sure that I need to run downstairs real fast and get my food delivery. Yes. I will be back in a minute. few minutes. My food delivery from Tim Bezos arrived, and it arrived during the early end of the window. It was like 3 to 5 was the window, and I was like, oh, if it's 5, my session will only go a little bit past. They delivered it at like 3:30, so fortunately there's no ice cream in the shipment. You mean on the right and left of that of what instruction? Dude, I literally have no idea what you're talking about. All right, back in a minute. It actually, I ordered a lot of green tea and stuff, so it might actually be, it's probably 2 trips at least for me, so we'll see what happens. This might be difficult. Now I'm looking for my glasses. I've got my mask on because in this building they want you to wear a mask down in the lobby. And I'm like, okay, I'll do that. See, I could take my Twitter photo. I can be one of the people who has their mask on in the Twitter photo. Look at me. I'm wearing a mask on Twitter. You know I'm a good person. All right. Back in a minute. I now have all the groceries. I just need to put a few in the refrigerator, and then we'll be done. Okay, everybody. That was a successful session. We still have more programming to do, but it was good. Should pass value get type, IR builder get it went high, and value IR builder get false. Pass those to what? To this, here, like that, and then, so that's the thing I was talking about during the stream about the 0 is undefined or whatever, right? But the thing is, oh, because we're computing both results, so it shouldn't, even if we don't use the 0 result, it shouldn't be undefined. Because otherwise it'll freak out and launch the nukes. Is that the point? We don't want LLVM to launch the nukes. Okay, now this is going to be ridiculous because this is one of those things that's super verbose in LLVM. I mean, maybe we can somehow okay, if it's 8, what do? We have to duplicate all the logic that we had in here to go from oh no, because okay, this is even more confusing because we didn't have to do this. FFS is bit scan forward, but we had count leading zeros. Okay, we'll just try to get it right for half of it for the leading zero part. So 64. So we want to say math result equals sub hold on, no, in the wrong file. Create sub from a constant of what was it? Okay. From a constant of 64, right, minus the scan result. All right. And what is this? This is some kind of create constant monstrosity. So we want 64 minus that, right? For 4, we want 32 minus that for some reason. We can actually do the 16 and 8. We'll just do that. And that'll get us closer to the answer. And then this is math result. Let's just do this. Okay, so now we have forward 28. That's completely wrong. Reverse 32, though, that's right. Our bit scan reverse is correct. Right? In fact, let's just turn off the assertions for a minute. Okay. So reverse is 32. Reverse is 16. Reverse is 5. 1, 2, 3, 5. Yeah. Yeah. 64. Yeah. I mean, that seems right. So we need the bit scan forward to be correct now. Wait, is it? Wait, what? Why? Because we didn't do the other subtractions here. Hold on. Why did that work? In bytecode runner, 16 minus temp minus 16, 8 minus temp minus 24, but that was because, okay, that was only because we didn't have an 8-bit operator. We do have an 8-bit operator here. Okay, so actually this part could, instead of doing this switch, we could just say size in bits minus the thing. That's actually fine. Only reverse needs to sub. Really? Do we add 1 if it's otherwise? Let's see. Okay, hold on. Math result is, so we actually have our own size here. Result type Well, no, we want the source type, right? So defen size. I thought I was going to have to do more complicated math, but I guess we don't. So we're going to do this. Actually, we don't know if we could do that yet. Hold on. Okay. CLZ is always +1, right? Okay, so if reverse, we do this, else math result is IR builder create add constant int get helper I32 1 scan result like that, right? No, because it didn't compile. What is going on? Function. Oh, it's not called reverse. It's called reversed with a D. What is it? Did we never get that? Oh. That's a little bit silly, but we're going to do it. I mean, that seems right. Right? GG's. GG's. Thanks for the help, by the way. Oh, I forgot to take off the be back soon, by the way. Sorry, guys. I just got excited and wanted to program. You wanted to ask if I learned about engine programming during the time I started my company in 96 or whether it was before. No, it was when I started the company in 96. No, I started just by doing it. There was no like, put your toe in the baby pool. You just start doing it. You need to know whether to use behavior that Intel refuses to document. I would say no for now, unless we add something to the compiler. Like I could imagine adding something that's like, use cool stuff that is not official, but I think we should stay with official things. But if you wanted to let me know what that was, I could make a note about that. We haven't done this type check here, by the way. Do I think x86 is a mediocre instruction set? Yes, for sure. But that's in large part because it just got glommed together over time, and a lot of it doesn't really make sense now. Like if you were to design an equivalent of x64 instruction set from scratch, well, first of all, you wouldn't put all the instructions in that are in there, and second, the encoding would be a lot better, right? But that's fine. Okay. Oh, for doing the other thing branchless? Yeah. I mean, I probably should have used a C move or something for sure. Okay. I have to do this type check, then we could check it in. Let's just do this. Name. Whoops. Name. What's going on here? Oh. I was like, what? What am I looking at? Name and type name. Same here. But this is not. Okay. I think its flag is a number. Okay. Let's make sure this still works, and then we'll test it. Bit scan forward. Hello, sailor. Bit scan forward 42.5. All right. Whoops. Well, there's that too. Intrinsics are globally only. Okay, so we need something. X. I mean, should I allow pointer types? I should allow pointer types in bit scan or pop count, shouldn't I? I shouldn't do floats because floats are like going to be on the FPU or whatever. So we could say integer or pointer. Just going to make sure this works on all the functions. Yeah. Okay. So we're going to say okay, so it accepted the pointer. That's great. Great, everybody. Do I have a working x64 compilation without LLVM? Yes, we have had that for years. It's just not particularly efficient. In that case, you have to do a move A input XOR BB, BSR, set ZB, inc A, dec B. That's a lot of instructions. Like, doesn't it seem like it should be so much simpler than that? You know? Especially, doesn't it seem like if you designed these bit scan instructions with singularities in them, wouldn't you design the singularities to be things that you could deal with easily? Like in one more instruction or something? Let me see. Bit scan. For a branchless version of this that uses only official behavior. A branchless version. Okay, so that's I mean, if it's documented by AMD, I mean, let's face it. AMD is like gonna be fine. That's still more instructions than I like, but it's better than the branches. Okay, move A input. The move A input is always there, right? So XOR BB to clear B. Well, hold on. Move B -1. Look at the bottom one. Bit scan reverse. Bit scan reverse B comma A? With B being the target register? What? Inc B. I don't get it. I don't get it. Okay. XOR BB, I'm looking at the top one now. XOR BB, bit scan reverse AA. Okay, so A now gets the result of the bit scan. Set ZB. Right, that's what we were doing before. So if the 0 flag is set, that sets B. Inc A to get the +1. I guess. Wait, we should have need the +1 because it's bit scan. Hold on. Dec B. So B is 0 or -1. And A and B. Right. So that's the standard. This top one is the standard trick of masking to 0 or not. Right. Yeah, that's a common trick. The bottom one, I don't know what that's doing. Wow, the chat just died. We have 455 viewers. Would it make sense to ban pointer math and force a union with an int? No. No. No, 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 no. Why would you? What is the utility of banning pointer math? The undefined result of BSR BSF is to not change the result register. Wait, really? To not change the result register? How do you get the value then? Wait, what? I must not understand what you mean by not change the result register. You mean oh, if it's 0, you mean. If it's 0, B would be unaffected. Oh, if the input to BSR, not result. Right? Do I get it? I feel like if it's documented by AMD, it's not really going to change. So we could try that version. I want to do a check-in before, because it's working, and I'm happy with that. So I want to run the tests and do a check-in, but then we could try that version out. try the game. Trying the game. Don't hate the player, hate the game. Actually, don't hate the game either. We're trying to make it real good. The hidden input register causes issues with out of order execution, but they just add very new instructions like LZ count instead of changing extremely old ones. Wait, is LZ count a different? That's what we looked up, right? That's what we're using, I think. All right. All right. Great. So maybe I check this in. There's probably a no check-in, right? Nope. GG's. Okay, so for this version, we move A to input, which is done. Move B -1. So like that would be, I don't know if I have an instruction like this prepped, but we'll use C. Move SX RCX -1. All right. BSR or dest, right? Dest -1. This could be like a 1 byte constant, right? That gets sign extended. Okay. BSR B comma A. Inc B. Move result. Oh, that's way better. That's super better, dude. So I just need to do these two things. Ink 64. This really could be ink 32, right? Let's make 32s. Those are going to be the same thing, but without the Rex W's. Hopefully, ink 32. Right? So now I need to move immediate. Okay. So I do a 32-bit version here. But I really want, I'm just going to hard code it, right? Let me get my T, water, move SX. Bengal spice. The new x86 instructions are scanning 0 instead of scanning bits, since the 0 input case has a more reasonable possible definition. That's the weird thing. The GCC ones were returning register size -1, which I don't know why you would ever want that in a count zeros instruction. That didn't make any sense. I was like, what's going on? Okay, move sign extend, R32. Wait, move. I want to move a constant. This instruction, I want move immediate. Hold on. How do I move an immediate? I can't find the word immediate. What's it called? All right, well, let's go to the move section and look at the 12 million things called move. Move. Immediate. There we go. Move immediate. Is there a move? Can I move an 8-bit sign extended? How do I get -1 in the register for 32 bits? That's what I don't know. I could obviously, okay, we can make it work and then we could work that out, right? So here I have a function that'll do this, right? This move 64 immediate into register output des that. Okay. So that's fine. Probably didn't do something right. Yeah. It crashes. Weirdly, it gets right answers till it crashes. Oh, it's on the 8-bit? Move EAX -1 is B8FFFF. Yeah, I was just looking for a smaller instruction. Yeah, see, that's what happens. If you pass this in here, it says it's less than or equal to uint32 max, and it goes B8, plus register index, right? And then F, 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 F. So that's what we're doing. I was just looking for something more compact than that. Unless you ask for size opts. Yeah, I mean, I'm fine with this, honestly. I just didn't want to be dumb and miss something that everybody knows. Because it seems like you do -1 a lot, right? Okay. Why would the 8-bit version now be broken? Let's just run it. Okay. Let's just look at what it generated. Bit scan forward. Move -1. Bit scan forward. Ink. And then this is garbage being generated by the thing. So I guess that's right. Let's just see where it crashes. Oh, it's in the 64-bit one still. Oh, because we printed pop count for Cafe Babe Food Face, but not the bit scan. Okay. Somehow it doesn't surprise me that it's a 64-bit version. Okay, so we go... Wait, why are we rotating? Wait, what? No, this is broken. I did a bad here somehow. This version, this is bad. This is bad. What? How did we get... Oh, because I put the prefix, guys. I put the Rex W right here like an idiot. Yeah. Don't do that. Please, don't do what I did. And instead choose life. Choose to succeed in the games industry. All right, great. That is much better than the version that I had, for sure. The size opt hack for this is OR Rax -1. Since OR can take an 8-bit signed immediate. Interesting. Built-in CLZ predates LZ count. So it inherits the undefined behavior of BSR. Why don't they make a new built-in? All right. I mean, very successful. Very, very successful. Update bit scan intrinsics for x64 back. I mean, maybe I'll ship another beta tonight because there were people asking for this. I could check the email to see if there's any other high priority bug fixes or just things that seem important. But honestly, I think a few people at least would be happy to get these in the short term. On integer and pointer types. LZ count is too new. You can't use it on default compiler targets. So I thought that I read, so there was like a caps bit for LZ count. And I thought that I read that if that caps bit was 0, the CPU still implemented LZ count. It was just in terms of something else, so it would be slower. But maybe I misread that because I didn't want a rat hole on it. It was in the middle of the thing. So I'm getting better enough at pull-ups that, how would you describe it? Like I can do more. Like I don't need as long of recovery. So I've been doing pull-ups again 3 days in a row. And I did like 5, and then I did 4.5, and then I just did 4, right? Despite the fact that I did some this morning and last night and all that. So like maybe I could do 6 if I give myself a rest day. I don't know. Could you write an OS in the language? Sure you could, yes. LZ count performs a literal BSF operation on old hardware. Okay. Palms facing in or out. Well, this one was in, but I do out as well. I switch it up. I'm probably pretty far from one arm pull-up still. That's jump and go down very slow. How slow is very slow? Like do you mean like do that normally, or do that when I'm too exhausted to do more normal pull-ups? Five to 10 seconds from time to time. Let me go try one of those. Yeah, it's pretty interesting. Called declines, and it's a way to do more exercise after being tired. Yeah, I get it. I will add that to the routine. That sounds good. I mean, there's no pull-up routine. It's just like I go to the pull-up bar many times a day, a number of times a day. Make sure you go all the way down so you don't tense up your tendons in the elbow. Okay. I'll try to remember that. Well, I almost don't want to open my email because sometimes opening my email makes me sad that I have so much junk. Compiler hang when the module parameter is a procedure. Okay. That sounds like something we could look at. If you try to make a module parameter a procedure type, the compiler seems to just hang indefinitely. Yeah, let me try this. Oh, you know what? Okay, before we do that, we need to take this program that we did here and make this an official test. All right. I don't remember. I don't think I have to add those. Yeah, those just get run always, anything in that folder. Let's try it. Okay, I guess I do need to put a main there. Hold on. Let me look at... Okay, yeah. Wait, what? Yeah, whatever. At least we know it's running it. And it's passing. Except, I think I actually need to do that. If you can't go 100% on the next full training day, you need more rest. Maybe, but I kind of want to get better at pull-ups real fast. You know what I'm saying? Okay. Add a bit intrinsics tests. Is there a pull-up competition coming? Not that I know of. Yeah, I think if I got moderately sore, I would stop for a bit. I feel a little sore right now. It's just different though. Like when I wasn't doing any pull-ups, and then I did like one, you know, I did that like 5 or 6 times over the day. And then I felt it for several days after that, you know, just like that one pull-up or one and then trying to do the next one, right? I don't really feel it now throughout the day or into the next day. It's not that big of a deal now. It's just I'm not fully recovered. So I can't do my max, but it doesn't really feel sore mostly. Although maybe I have a little right now. We'll see. Have I done rock climbing? I have not. There's the 4OX cafe to food thing. I want this actually other thing is serious, so I want to attack that. Like I mean serious in the sense of it crashes the compiler. Okay. If this ends up being really gnarly, maybe I won't do it tonight. We'll see. He just went into one of the modules. And he did this. Now, this is wrong because this says proc and this doesn't. So I wonder if that's actually the mistake. Anyway. Whoops, no, that's not what I want. Put that there. Yeah. But what if I do this? Okay, I will email him. So the hang is because you said attached to debugger and not attached to debugger proc. I mean, it's stupid that it hangs, and I will fix that. But you have a workaround for now, which I'm sure he'll be happy about. That was sent 2 hours ago during my timer stream. So that, how is that for fast tech support response? Okay, so the question is, why is it hanging in this case? Like, if I do that, it's going to hang. So why is it hanging? Probably don't need disassembly, but so it's in. Is it infinite looping in report? No. Wait. Oh, we have a go-to. Wait, what? Okay. How's that for a slurp? Okay, I think Expert is not changing here. So Expert before this line is A638, and after it's A638. Okay. Let's explain, yeah. New code. All right. I mean, that's still not like good, but it's better. The hang is fixed in the next beta. Error message still is not great, but it is better. Okay. Fixed hang that can happen when undeclared identifiers can happen in some cases, such as module parameters. Guys, you know what? I never tested those intrinsics on Linux. And I don't think I have WSL on here. There's a whole VirtualBox thing, but I never use that. So I think I'm going to run tests real fast, and then I'm going to test the laptop. Because we don't know if those GCC intrinsics work. Whoops. I also misspelled built-in pop count or something. Let's see. Built-in. Are there not? Oh, pop count L. No. Are there not 2 underscores? I would have assumed that there was 1, but it looked like there were 2. I don't know. Make. Oh, I updated the wrong thing. It's 2 at the beginning and 1 in the middle. Really? Okay, I must have misread the website that I was looking at, or maybe that website was wrong. Make. Well, it stopped somewhere. I can't see in all the errors. Oh, no member named U16. And undeclared identifier built-in pop count with 2 underscores. Did you mean built-in pop count with 1 underscore? Why, yes, I did. Yes, I did. Yes, I did. Built-in pop count. Then we put underscores here on the type names. And then I make. Still a problem. What is the problem? Overload, no viable overload equal. What? This is in the bit scan. Result equals 64 minus temp. What? What is result? Oh, right. These are result.s64. Wait, no, it's scan equals. Wait, what? Yeah, okay. It's not result, it's just scan. Scan is the value. Okay. Now we will type make. It seems to be making more. Seems to really be making more. Yeah, Jacob Lee Zero has really helped out sometimes with LLVM and or x64 things. Okay, we're getting a compiler executable on Linux. We're making the tests. We're doing the LLVM tests. And, oh, they're not alphabetically sorted here, so I don't. Bit intrinsics. All right, bit intrinsics passed. in LLVM. I should also run it in compile time execution. This particular test doesn't do compile time execution, but I will do it. I will do it. Okay, the x64 now. Bam. Easy peasy. It's cranking through them. And then oh yeah, I was going to do the bit intrinsics. So let's do standard bit intrinsics dash run hash run main semicolon. Right? Okay. That didn't work. When I do the compile time execution, that didn't work. The answers are wrong or something. Okay, so there's a little more to do. Unfortunately, you can't see this because it's on the other laptop. So LLVM works, x64 works, but again, in this really perverse way that these higher level things are supposed to be easier, but actually screw you. The bit scans don't actually work correctly. Even though we wrote the machine code 2 different ways and it works fine on both machines, the higher level thing doesn't work. Okay, where is it? I don't want to have to GDB this. I'll do it, whatever. Oh no, because it's running in the compile. I don't want to GDB this. No. So it looks like the bit scans are kind of all hosed. Wait. The bit scan forward. Oh no, bit scan. Okay, it's saying 8 for things that are much bigger. For bit scan reverse. Okay. So my minuses are wrong. But the minuses that I did in LLVM are right. So I guess I want to do those, right? Right? Is it just word size minus? Why am I getting 8 all the time? I could make this code a lot shorter too. Let's just see. Count leading zeros of all f's should be 0. Wow, I have so many windows open on this machine. Okay. So temp 38. Scan 8. What? Temp is 38. So I'm looking at this code here, just to illustrate. So I'm here. We've fixed the other pop count stuff. I put a printf here that prints temp and then scan, which is this thing down here. And it's saying temp is 38 for a number that is 64 ones. So that's very confusing. But then 64 minus temp is 8? What is even going on? I'm so confused. Oh, wait, I'm drawing in hex, guys. Hold on. Hold on. Lol. That's why I'm confused. I was drawing in hex and they happened to look like integers. Because I did U8 value. Oh, hey, you know what would be good? What would be really good is if I left enough room in the number to store the information. Yeah, that's just because I copy pasted from the 1 byte version. All right. Now, this is needlessly verbose here because I could basically pack this. I could just say, all of this could just say if input.u64 scan, because this result was wrong, scan equals 64 minus. It could just be a one-liner, actually. So we're going to do that. But first, we're going to make sure it runs. It does. That's great. Okay, success. Huge success. Super good. Now I'm going to convert it to a one-liner. So we're going to say if input.u64 scan equals 64 minus input.u64, right? Else, implicit else keep the scan is equal to 0 that we assigned above. Okay. You'll see, I'll re-update it on the screen here so y'all can see. But it's actually much less objectionable when I write it this way. I'm going to do the 64 and 32 versions. Bam. Bam. We'll test that. Oh, it didn't compile. Oh, because I didn't put my parens around the if condition because I'm used to programming in a language where you don't have to do that. All right. Okay, still passes the test. So, gonna do the 16-bit. So 16 minus thing minus 16 is actually 32 minus thing. Right? Like this thing here. Remember when I was like, I'll come back and simplify this later. So that's just 16 minus temp plus 16, which is 32 minus temp, which is the same thing it is down here. Right? We're now typing make, and now we're running the test. It still passes the test. Oh, wait, no. No, it doesn't. Why not? Oh, no, that's a different reason. Different reason. I subscripted the value wrong again. Never mind. Okay, passes. And now I do the 8 bits, and that's just going to be a 32 minus again. A 32 DKP minus. I can't believe I thought that hard about that when it's just 32 minus. Sure someone in chat was saying that at the time. Okay, I broke that one. This one was 8 minus is 24, which is 32 minus temp. Oh, I subscripted wrong again. All right, commit fix GCC bit intrinsics. Okay, so you could see what these became during the hidden camera session. So all of these massive code blobs here are now going to change before your eyes. Boom. That's what I was just doing now. So like these are all 32 minus and then the thing. And it's one-liners instead of being huge, big, fatty fats. So I'm happier with that for sure. You could SSH into the laptop and use Emacs and terminal on stream. If I even knew what the IP address was, is it running SSHD, the default Ubuntu? I guess it is. Do I know what my password is? Am I missing FFSLL? I didn't think so. Oh, no, you know what? I think I just broke this. Wait, no, I left it. I think you're right. Why? Why is that working then? So with CLZ, I was definitely using the non-LL until here. But FFS, yeah, I think you're right that should be LL. But we definitely do bit scans on 64-bit numbers. So like, I don't... Oh, no, you know what it is? We don't do bit scans on 64-bit numbers that are 0 until the high bits. Yeah, what you just said too. So let me add a test to that. And that's going to take me 20 seconds to load the file in WSL. So we'll just do a bit scan with, like, you know, E000, whatever. Multitest E0000000000000. And what even are the pop count is going to be 3, right? The bit scan is going to be something in 64 because it's still high bit. Let's do 6000, right? So it's 63. And, well, 8, wait, no, 4, 8, 16, 32, 48, 60, 61, something like that. Let's see. Yep, so it is unhappy. It is assertion failing in the bit scan forward, which is not really surprising. I mean, I should run this test on all the things on Windows as well, because it is a little bit of a different case and something else might be broken. All right, so we're making with the LL. The LL has been added. And we still don't pass. So the pop count is correct. Oh, it's just my my expected numbers are off by 1. It's 62, 63. Which makes sense because it's only 2 bits. Wait, what? Oh, I didn't change the pop count from 3 to 2 when I took off the high bit. There we go, passing. All right, so I'm checking in that. I'm going to run the tests here real fast again. While that's running beautifully, we will update back over here with that new test case. And what I was doing the following. So I took the run directive that runs at compile time out of the bit scan intrinsics. So if I just run it, oh, let me rebuild the compiler, by the way. So if I just run it, like it's not going to run them, right? But you can do this. You could say dash run, run main, right? And you just boop, boop, diddly boop. So this is the test that I just added. It's 64 bits with 2 of the high bits set, but not the highest most bit. I mean, you could make a test that does 1,000 different numbers where it like dynamically sets the bits and all that, but it's fine for now. Okay, but let's test it. Okay, that's LLVM. That's x64, so everybody's good. Everybody's good. built in with triple underscores. Yeah, you can. So for all these intrinsics that we did, it's pretty straightforward to write these functions in like C or whatever if you were to sit there and do it. It's just they're really a lot slower than if your CPU does it, especially for 64-bit numbers or whatever, right? And there are tricks where you can write them faster. So population count especially, there's a trick where you break the number into two fields and you do like parallel adds and stuff, but it's just better to use the intrinsic. Any questions about what we were doing? I had a good time doing that. Except for the frickin' LLVM basic block situation. That was miserable, but the rest of it was good. For LLVM, like when I was searching, it seemed like there should have been an LLVM bit scan intrinsic, but I could not find it. So we use CTLZ or CTTZ and then do a little bit of math on the result, which honestly is not great because you want it to map exactly to the instruction that you want. But still way better than writing it yourself. Do most game engines use CPU level bit intrinsics? I would say they use them in limited places. They don't like use them all over the place. The thing is, though, when you want one of these, you really want one of these, right? You don't want them all the time, but when you want them, you want them. Do all modern CPU architectures support this? These particular operations, yes, roughly. Like, I mean, you might have a CPU with a count leading 0 instruction, but no bit scan instruction or whatever, but approximately yes. I'm allowed to look at chat now, yeah. Not looking at chat was only for the high intensity 3 hours. I think sun chips are addictive, honestly. So we didn't need this stuff here. That was silly. We actually probably could use this. So we have this bit array, right? Let me see. Maybe we don't need it in bit array. Oh. This could be sped up using the new bit scan intrinsics, right? Bit scan forward, right? Well, we support reversed whatever, but for sparse bit arrays. Like, the thing is, if your bits are roughly equally to be set or unset, then using bit scan doesn't really help you, right? But if you've got a 64-bit word and there's like, you know, 3 things set or whatever. The thing is, you need to make a copy of the thing, and then you use the bit scan intrinsic, you do a shift, you clear that. You have to like -1 it. Yeah, I don't know. You could do a pop count. You could just do an early reject and pop count of 0 as well. Anyway, so the problem is variable shift, I believe, is still honestly not that fast on x64, which is a pain in the butt. And so once you hit the next bit, like, you have to clear it. And I don't know how to clear it without doing a variable shift. And that kind of sucks. If anybody knows a good pattern for this. But you can see how this is just silly. Like, let's iterate over 63 things. If it matches, do the ting-tangler, right? You can clear least set bit without shift, really. I mean, okay, you could do -1. What is the hacker's delight way to do this? If you subtract 1, you clear that bit and set everything. Oh, you subtract 1 and you AND with the previous value. I know these things. I know these things. I know these things. To clear the least bit, subtract 1 and AND it with the old value once the bit scan tells you where to go. But that's for bit scan forward. How do I clear the most significant bit for bit scan reverse. Is there a trick for that? I kind of feel like there wouldn't be. Yeah. I'll just write these down. Yeah, this is all in Hacker's Delight. And I was like, I'm not going to use this anytime soon, but I totally would. It doesn't work in the other direction. Yeah. So you would make two versions of this thing. It's still up in the air to me how much it is worth supporting reversed iteration everywhere. Like maybe it's just not worth it. Because data structures can be simpler and more focused if you don't have to worry about them going backwards. Oh, and we actually said let's not bother with reverse. In which situations might one use a bit array? Well, if you want to know, for example, it's just like it's like a Boolean set, right? Like if you have a bunch of things and you can assign an integer to each of the things, then the bit array tells you, is that thing in the set or not, right? And it's very fast because it doesn't use much storage and so forth. I could see, I think we use this in the Sokoban game. Let me see. Maybe not. Oh yeah, I use it for wall data. Okay. So wall data in the Sokoban game, you might have seen, it's basically just like a bunch of little cubes, kind of like Minecraft or something, and it's usually invisible colliders, although if we're working on a level and it hasn't had graphics done yet, then it's visible, right? So that's like a 3D volume, but it might be kind of sparse. It might have big holes in it and so forth. And so we use a bit array to store 1 bit per cube inside the volume about is that occupied or not. And then we generate the mesh based on that. It looks like they also are using it for visibilities for some reason in the renderer now. Explicitly specifying a reverse iterator is better than trying to use an iterator in reverse. Yeah, I mean, I maybe agree with it. So this reverse thing was added before that was added. And honestly, I feel like, well, not that reverse thing, but here in for expansion, I kind of feel like 4 arguments to for expansion is a little too confusing. Like it's a lot to think about all the time. Whereas if it's just 3 arguments, it's like whatever the data structure is, whatever the thing is to iterate over, and then whether you want to go by pointer or not. Like, I can remember that. Like, a 4th starts to get cumbersome. So, yeah, maybe we take that out. I'm sort of feeling we might take that out. But the thing is, yeah, I don't know. Yeah, specifying iterators by name is still a thing, by the way, yes. Do I ever get angry at myself when I'm reading my own comments? No. Why would I? Yeah. I'm gonna put that on a request for comments to the beta people. I'm gonna write that down. Because sometimes when I simplify things, I just get so much happier. And if they're not really pulling that much weight, I guess the reason to keep it would be for consistency. Like you can reverse for loops for integer ranges and for regular arrays. But maybe we just say, look, the compiler only automatically does that in those two cases. And if it's a custom iterator, you just do it yourself with a different name. Like it would just give you an error otherwise. That seems good, right? I thought I had a piece of paper here where I had written down, oh, it's over here. All right. Bit ops crossed out. Use ROF for reverse for. Yeah, I mean, it's not the question of indicating it. It's a question of how is it implemented for different data structures. How many instances of reverse iteration do I use? Not that many. I mean, okay, so most of these, actually, here we go. In the whole Sokoban game, which is 100,000 lines, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is not nothing. It's not nothing. But most of these are probably built-in arrays. So most of these would be fine anyway. Could use a bit reverse intrinsic to support reverse iteration. That is probably true. The problem, we still would have to do, you know, a 64 minus situation, but I think that would work. Of course, we don't have bit reverse yet, but we've shown how much work it is to do something like that. It's not that much. That's quite a few lines. I mean, the for loop is one of the main workhorses of this language. So you would expect to see a lot of for loops, and you would expect to see then use of features in the for loops. Would the iterators ever want to support things with indeterminate length a la generators? I mean, I don't think that's a good idea in the sense that that's like a functional language wankery that is inherently inefficient. Like if you want a generator, just call a function in a loop, right? That said, like the argument for doesn't know what the argument is doing if it's a custom for loop. So yeah, you could make that. You could have, instead of a bit array, you could have like a thing that generates items randomly. Because all that happens is it expands a macro and you decide when you're done. So you could, You could loop infinitely generating things. You could draw graphics to the screen in here. You could do whatever you want. You're not sure if GCC supports bit reverse. Maybe if a for expansion doesn't define reverse or pointer, it auto gets assert reverse equals false. I mean, I don't think I would do it that way, but the compiler could detect it. The thing is, it wouldn't know, like, it doesn't know from this function because maybe you have something else called for expansion. Like, this isn't a reserved word, so you could name anything you want for expansion, even a macro that looks like this with different arguments. But when it gets applied to the loop, yeah, we could probably, if you left it out, we could detect that. It's just we don't do that right now. And there are maybe things that make it more confusing. Like we do overload resolution with these and everything, right? So like, I don't know. But yeah, that was definitely on the list of things that I was thinking about. No, you don't want to reverse the whole bit array. No, these bit arrays could be gigantic, right? So when we're talking about bit reversing during iteration, it's just for it's just on a per slot basis. But yeah, I was a little unhappy. Like look at how much more code it is to support reversal here, as opposed to just this. Like this, if I want to know, hey, how do you iterate over a bit array? If I see this, I'm like, oh, that's nice and short, right? Whereas this one is like, yeah. Although actually, so this for expansion, right? This for expansion iterates over everything. It treats them as booleans, right? And gives you all the booleans, even if it's 0. This only set or unset is the one that would skip zeros. And we could implement that by just XORing the thing and then using the same loop, right? Yeah, well, that's actually what we do. Programming is fun sometimes. Yeah, the other reason to remove it is, like, programming is fun sometimes. Like, hey, I want to make my bit array, and I want to make this iterator for it and all that, right? But, like, it gets really unfun really fast when you start having to do the C++ thing of, like, make this method, and that method, and that method, and that other one, and that other one. And I always hate that, right? And this starts to be that way. Like, you don't have to implement reversal, but it's there. And if you don't implement it, maybe you feel kind of bad about it. Whereas if it wasn't there, maybe that's fine. You feel better. It's lighter. It's breezier, right? I'm leaning toward this way. If it's variable shifting that's a problem, then a tiny lookup table might be faster. Yeah, that could... I mean, a 64 entry lookup table. I mean, that's still a lot of bytes, right? It would be 8 bytes times 64. It's 512 bytes. Where cache lines are what? They're 32? Or are they 16? That's a lot of cache lines. for, you know, but if you're only going forward, again, it's very fast to clear the bit, actually. It's faster than reading. I mean, you have a byte swap intrinsic, so you could do byte swap and then somehow swap the bits. Like, you could swap 4 by 4 and then 2 by 2 and no, I don't know. Oh. Yeah, I mean, like seriously, so here's what this looks like with both forward and reverse, all right? And over here on the right, let's just look at what it looks like with just forward, all right? So here we go. I think I did this during a thing once, but whoops. So I'm going to line them up. And we're just going to go, hey, it's always forward. We'll leave the comment. That goes in there, and then the rest of this goes away. And in fact, if we use the... Yeah. I mean, look at the difference. Oh, I said this right here. Here's how simple it would be if we didn't support reverse. Yeah. Like just this is so much nicer than this. Oh, and also, by the way, yeah, that would go. Like, this just is nice. Like, I can look at that and go, oh, I see what that's doing. This is like, Never mind. The C++ version would be like 8 pages, so we're still doing great, but you know what I'm saying. Wow, I guess I killed chat with the stream today. I do not see very much chat happening. I'm going to stop my local recording now. Okay. Statically allocate a 64 entry buffer. Do it in reverse. Reverse up to 64 entries at a time. I don't know what that means. SIMD? Not right now. No. Like, SIMD, I think, happens with inline assembly, which we might start doing just with a stupid ass. We might make our own stupid assembler that only does a few AVX instructions or whatever. It's just there are architectural issues to solve there. Like, we have to somehow hook into that, especially in the case of LLVM. We have to give LLVM like a blob of binary and have it call into that. I don't know if you could even do that. We have to have the inline assembly integrate with the rest of the compiler so that you could like use variable names and stuff. It'll be interesting. What if you could code the function separately? Yeah, I mean, that's sort of what we're talking about, except instead of it being a reverse argument, it's just, it would have a different name, which honestly I think is fine because there's a lot of different things you might want to do, right? Iterate words in reverse, but iterate bits forward and then reverse them with a static buffer containing the set indices. Oh. So you would like write out the indices forward and then run over that backward. That seems a little wasteful, but I mean, if it's faster than the other thing. I mean, the good thing is, you know, the indices fit in 1 byte each, right? So it's a lot smaller. I can see that. I mean, do you want to try to somehow do 6 bits each somehow? Probably not, but you could. I mean, you could pack 4 entries into 3 bytes. No, I don't. That doesn't sound good. Doesn't sound good. Well, I think that's going to be the end of the stream. I'm a little... I need a break. That was a good focus session. I'm happy to have done that. I think we'll change up the format to be like 2 and 2. Because I was still ready to go after the 3 hours was up. I just needed a little break in the middle. So it'll probably be 2 and then 10 minutes and then 2. Is it possible for someone to make their own macro? I don't know what macro library means. Let's find... Have we really been going 6 hours, 15 minutes? Is that like really what happened? No wonder I'm tired. All right. It's almost like I'm a pro streamer with these durations. You can byte swap, so you only need 8 3-bit entries. 8 3-bit entries. I'm not seeing how to do that, but that's fine. Fine. Who do we raid here? Dinosaur stream. Look at that PC case. It's like totally transparent. That is the kind of thing that looks great in the beginning, and then all the dust blows around in there, and you're like, dust farm. Dust farm. Although you could like embrace that. Why doesn't someone make a water-cooled PC that's basically like a lava lamp? And it's just got a huge amount of water in it as a heat sink, and you heat part of it, and that makes the lava lamp go, right? I should get a lava lamp. I had one of those when I was a kid. Refactor has spread to player motion. Renditions of the Awakening. I mean,
what am I doing in here? Projectiles number, otherwise if compare tag to ragdoll.
he's got things up in Unity Game Engine. So we'll do that. Thank you, everybody, for coming by. And I'll see you later on.